the largest, most powerful, and most complex space telescope ever built.
James Webb.
James Webb.
James Webb Space Telescope.
James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth. The Post's claim that the telescope captured the object changing its trajectory.
The James Webb Space Telescope, already a monument to human ambition and engineering precision, has once again shaken the scientific world with an observation that borders on the unimaginable. Amid the silent depths of interstellar space, it has detected what appears to be artificial illumination emanating from the object designated 3E Atlas, a celestial visitor traveling through our solar neighborhood on a hyperbolic trajectory, similar to the infamous interstellar objects Oumuamua and Borisov. But this time, the data gathered by Webb's instruments defies easy categorization. What should have been a cold, inert rock drifting through cosmic emptiness instead glows faintly but persistently, with a spectrum and temporal pattern that suggests the light is not natural in origin. The discovery has cast a profound and eerie light across the scientific community, sparking debates that stretch far beyond the boundaries of astrophysics. Before we start, smash the like and subscribe buttons for more updates.
Astronomers are continuing to track a newly spotted object, likely a comet, from outside our solar system. The interloper, named 3I Atlas, was first spotted on July 1st.
When the James Webb Telescope turned its golden mirrors toward 3I Atlas, astronomers expected to find a small, rocky interstellar body, perhaps composed of ice and dust, a relic of another star system wandering through the void. Yet the photometric data began revealing an anomaly that could not be dismissed as reflection or sublimation. The light from the object pulsed at intervals too regular to be random, and its spectral profile contained emission lines inconsistent with any known natural chemical luminescence. The glow was faint, barely above the background cosmic radiation, but distinct enough to persist over multiple observation periods. Webb-sensitive instruments designed to detect the faintest infrared signals from the early universe recorded a consistent signal pattern that resembled structured light, modulated as though generated by a technological process. The first suspicion was instrumental error. The Webb team meticulously recalibrated sensors, cross-checked data with the Hubble Space Telescope, and verified with ground-based observatories. Yet every confirmation deepened the mystery. The signature remained the same, a soft, rhythmic pulse in the infrared range, repeating at exact intervals over several days of observation. When Webb's near-infrared spectrograph analyzed the frequency spread, it revealed an energy distribution that bore a closer resemblance to a controlled emission source, something akin to the kind of light used in advanced propulsion systems or artificial illumination designed to operate in the vacuum of space. It was neither reflection nor thermal radiation. It was structured light, coherent in a way that nature rarely achieves without intervention. Scientists began comparing the data to all known natural phenomena: auroral emissions, outgassing events, ionization trails, or reflective glints from tumbling surfaces. None of them fit. The object's trajectory, already established as interstellar, ruled out it being a piece of human-made debris. The energy output of the illumination was too stable to come from sublimation or spontaneous chemical reactions. And most curiously, the light seemed to respond faintly to changes in solar flux, as if compensating for external light levels, maintaining a nearly constant output despite shifts in illumination from the sun. This adaptive behavior, subtle though it was, marked the first truly alarming indicator that what Webb was observing might not be a mere chunk of rock at all. 3I Atlas itself had been catalogued months earlier as another unremarkable interstellar visitor. Its orbital parameters indicated it came from the direction of the Lyra constellation, traveling at immense velocity, unlikely to ever return. It was only during a follow-up survey, an attempt to study its composition in infrared, that the strange luminescence was noticed. The faint glimmer appeared as a narrow-band emission in the near-infrared spectrum, centered around wavelengths typical for engineered diodes or laser systems. At first, some researchers suggested it might be the result of exotic minerals fluorescing under cosmic radiation. But this hypothesis crumbled when the periodic modulation became clear. Natural fluorescence doesn't switch on and off in exact repeating cycles. Within the scientific community, disbelief gave way to cautious awe. Meetings at NASA, ESA, and the Space Telescope Science Institute quickly became charged with both excitement and apprehension. If confirmed, the detection would represent the first empirical evidence of extraterrestrial technology. A sign that intelligent life had not only emerged elsewhere, but had also created something enduring enough to survive interstellar drift. The implications were staggering. Artificial lights imply energy control, design, and purpose. Even if the source was derelict, a fragment of a long-dead civilization, the very existence of such a construct would rewrite the cosmic narrative. The light from 3I Atlas was not bright enough to be visible to the naked eye, even through large telescopes, but Webb's instruments could dissect it with extraordinary precision. The near-infrared camera captured subtle variations in intensity, while the mid-infrared instrument detected faint heat signatures inconsistent with a natural body of that size. The object seemed warmer than expected, given its distance from any star, its temperature hovering slightly above what physics predicted for an inert rock drifting through interstellar cold. This excess heat, while minimal, hinted at either residual power or ongoing energy generation. Such a result sent theorists into a frenzy. Could it be a fragment of a probe? A decaying vessel? A self-contained light source powered by an ancient reactor still weakly functioning after millions of years? As data accumulated, models were built to simulate what kind of artificial mechanism could sustain such emission. Some physicists proposed that the light might be generated by photovoltaic remnants or by photonic propulsion systems designed to maintain stability in flight. Others suggested the glow could be an automated beacon, pulsing intentionally to announce presence, or more hauntingly, to navigate between star systems. The regularity of its signal resembled a code, though decoding it proved fruitless. It lacked the structured information content typical of communication, appearing instead as a maintenance rhythm, a repeating sequence to preserve synchronization or control. What made the finding even more compelling was that the emission appeared localized. It wasn't diffused across the object's surface, but concentrated in small defined points, suggesting discrete sources rather than a global glow. Webb's high-resolution imagery, though limited by distance, hinted at tiny reflective or radiative nodes distributed across the surface, perhaps panels, apertures, or light sources embedded in a rigid structure. This distribution was inconsistent with a natural asteroid or comet nucleus, both of which exhibit irregular albedo patterns. The data hinted at geometry, arrangement, order, and symmetry, and those are hallmarks of design. While some astronomers urged caution, pointing to the dangers of wishful interpretation, others argued that the burden of proof was now on those claiming it wasn't artificial. Nature, after all, seldom arranges matter in ways that pulse rhythmically, emit structured infrared light, and sustain temperature anomalies in the freezing dark of space. The object's consistent signal over weeks of observation suggested durability and intention. It was as if 3I Atlas carried a light that refused to die, a whisper from across the stars preserved in photons. The discovery has ignited new debates about the probability of interstellar artifacts and the longevity of technological civilizations. If 3I Atlas truly bears artificial light, it means that some civilization somewhere mastered not only technology, but interstellar engineering, sending objects capable of surviving cosmic radiation, micrometeoroid bombardment, and eons of travel. It also forces a reevaluation of how we define life's persistence in the universe. Perhaps the true legacy of intelligence is not biological survival, but technological endurance. If the lights are remnants of machinery, they may have been shining long after their makers vanished, drifting silently between stars, a cosmic tombstone glowing in the night. The James Webb Telescope's sensitivity makes it uniquely suited for such detection. Unlike previous observatories, Webb can peer into wavelengths that reveal heat and composition with unparalleled accuracy. It can distinguish between reflection and emission, between rock and alloy. Its instruments are so precise that even distant flickers can betray the presence of structured materials. This capability has now opened a doorway into a new era of observation, one where astronomers must account not only for natural phenomena but for the possible signatures of technology, what some have begun calling technosignatures. Artificial illumination, coherent emissions, and anomalous thermal signatures all fall into this category. 3I Atlas, therefore, may be the first confirmed case of a technosignature observed beyond our solar system. This event also underscores how the search for extraterrestrial intelligence has evolved from speculation to measurable science. For decades, SETI efforts focused on radio waves, expecting civilizations to broadcast signals intentionally, but the universe may not speak in our frequency range. The faint lights from 3I Atlas demonstrate that technological remnants, be they probes, beacons, or derelicts, might outlast communication itself. Civilization's fingerprints could persist as silent mechanisms glowing softly across time. Detecting them requires not only curiosity, but the patience and precision of instruments like Webb, which can catch a whisper of light billions of times fainter than a candle seen from another world. Within observatories and laboratories around the world, teams have begun modeling how such an artifact could exist. If it is artificial, it must have originated from a civilization capable of interstellar travel, or at least of sending long-range probes. The energy demands alone would be monumental, implying mastery of propulsion, resource utilization, and engineering far beyond our own. Some have theorized that it could be part of an ancient network, a series of automated objects designed to survey or seed regions of the galaxy. Others imagine it as a derelict, the last remnant of a journey that never reached its destination. Either possibility changes humanity's place in the cosmos. For if such an artifact can drift into our detection range once, there may be countless others unseen in the Black Sea between stars. The discovery has also sparked profound philosophical discussions. The light detected from 3I Atlas may not be a message, but it communicates something nonetheless, that intelligence has touched the universe beyond us. It evokes the same mixture of wonder and humility that accompanied the first images of Earth from space, the realization that we are part of a much larger story. Some thinkers have suggested that even if the object is inactive, its light might serve as an unintentional message across eons, a cosmic echo of creation, reminding any who find it that they are not the first to gaze upward and wonder. The data from Webb continues to pour in, offering more detail with each observation cycle. High-resolution spectrographs have identified periodic shifts in the emission pattern that could indicate rotation, or possibly the functioning of internal mechanisms responding to external stimuli. The light curve, plotted over time, shows consistency rare for random processes. There is a subtle variance every few hours, as if panels or facets were turning, catching and redirecting faint starlight, or perhaps adjusting for orientation. The possibility that the object is still partially operational, perhaps running on residual energy reserves, cannot be dismissed outright. Even as the scientific community maintains its caution, the excitement is palpable. The detection challenges our understanding of interstellar objects. Oumuamua's strange acceleration was once the height of speculation, prompting whispers of artificiality, but the lack of direct evidence kept it in the realm of hypothesis. 3I Atlas changes that dynamic by offering something measurable, visible, and persistent. Artificial light is not ambiguous, it demands explanation. And yet, the more data gathered, the more the mystery deepens. Every new observation affirms the light's presence but refuses to yield its cause. The potential implications for physics and engineering are immense. If the light is indeed generated by a technological source, its endurance over interstellar timescales suggests materials and energy systems far beyond current human capability. Radiation, collisions, and the sheer cold of space should degrade any known technology over such durations. The persistence of light implies either an incredibly robust design or self-repairing mechanisms. Some researchers have speculated about nanostructured surfaces capable of harvesting interstellar particles for energy, a concept once considered purely theoretical. If such a system exists on 3I Atlas, it would mean that another civilization discovered practical methods for perpetual operation in space's harshest environment. This raises questions about intent. Why would a civilization send such an object into interstellar space? Was it a probe, a monitor, a vessel, or a memorial? If it carries no message, perhaps its purpose was purely functional, a machine designed to survey, map, or explore without expectation of return. Its artificial lights might have once served as navigational aids or energy emissions for communication or synchronization. Now they remain as residual echoes of its mission, flickering like a beacon of forgotten purpose. The study of 3I Atlas has also highlighted the extraordinary foresight behind the James Webb Telescope's design. Its ability to detect such faint structured emissions was never conceived with alien artifacts in mind, yet it has proven capable of revealing what no other instrument could. The event stands as a testament to how technology built for one purpose can open doors to entirely new frontiers of knowledge. Webb's discovery has effectively redefined the parameters of the search for life, expanding it from biology to technology, from living organisms to the relics they leave behind. The deeper astronomers probed into the enigma of 3I Atlas, the more intricate and fascinating the portrait became. Every new dataset, every spectral refinement, seemed to whisper the same impossible truth, that somewhere, at some time, an intelligence had reached beyond its cradle and sent this object drifting between stars, wrapped in a sheath of faint, enduring light. Yet, within this revelation lies a labyrinth of technical puzzles. The challenge was not only to confirm the presence of artificial illumination, but to interpret what the characteristics of that light meant. It demanded an understanding of engineering possibilities that human science has only begun to imagine. At first, attention turned to the physics of endurance. Light emission in the void is wasteful. Any radiative source loses energy to the cold vacuum. For the emission to persist across millennia, or even millions of years of travel, it must either draw on a power reserve of extraordinary density or continually harvest ambient energy. The second option provoked special excitement, as it implies technology capable of energy scavenging on an interstellar scale. Some theorists speculated about photonic metamaterials, structures designed to convert cosmic microwave background radiation into usable power. Others invoked the concept of quantum vacuum fluctuations as a source, drawing energy from the minute instability of empty space. If 3I Atlas carries such technology, it would demonstrate mastery of physics at levels humanity barely comprehends. When researchers reconstructed possible timelines for the object's journey, they found that 3I Atlas might have traveled for tens of millions of years since leaving its origin system. During such immense timescales, collisions with dust grains, cosmic rays, and gravitational interactions would normally erode any surface, destroy any coating, and extinguish any functioning mechanism. Yet the light endures, faint but rhythmically intact. This observation forced scientists to reevaluate long-held assumptions about material degradation in deep space. Perhaps the artifact's creators employed self-healing nanostructures, able to rearrange their atomic lattice to repair damage automatically. Such a principle has been theorized for advanced nanomachines, but never demonstrated in practice. If the surface of 3I Atlas truly possesses this property, it could represent the most durable material ever encountered. Further intrigue arose from the rotation dynamics inferred from photometric data. Subtle fluctuations in brightness over each cycle suggested that the object rotated once every 11 hours, yet the pattern did not match a simple tumbling motion. The modulation in infrared intensity indicated stabilizing control, perhaps through gyroscopic mechanisms or residual electromagnetic fields. In other words, the rotation was deliberate. A natural body would spin chaotically after countless perturbations, but 3I Atlas exhibited balance, as though some ancient system continued to maintain orientation. If such stabilization is ongoing, it implies that even in its ancient and possibly derelict state, the artifact retains functional subsystems. The geometry inferred from light curve analysis inspired feverish discussion. Modeling the pattern of illumination suggested a roughly elongated shape, but with planar facets arranged in mathematically regular intervals. Some reconstructions imagined a hexagonal array of panels, others a cylindrical body with symmetrical outcroppings, perhaps antennae or radiators. Whatever its form, the structure hinted at intention and efficiency, a design optimized for endurance, communication, or propulsion. The notion that the James Webb Telescope, built to look at the first galaxies, was now mapping the outline of an alien machine drifting between stars struck observers as almost poetic. Attention then shifted to the question of composition. Webb's spectrographs revealed trace features around wavelengths associated with complex alloys, possibly titanium-based compounds mixed with silicates and elements unknown in ordinary meteoritic samples. This raised the tantalizing prospect that 3I Atlas might contain materials synthesized under artificial conditions, alloys engineered for radiation resistance or superconductivity. Some peaks in the spectrum did not correspond to any known elemental transitions, leading to speculation that the object may contain isotopes rare or non-existent in our solar neighborhood. The mere identification of such exotic matter would expand the periodic understanding of stable nuclear configurations. It would also imply that the builders possessed mastery over atomic manipulation to a degree exceeding current terrestrial capabilities. The behavior of the light itself remained the central mystery. Each emission cycle contained subtle sub-oscillations, as though multiple sources were interacting in harmonic interference. When the light curves were transformed into frequency space, they produced repeating mathematical ratios reminiscent of resonance patterns rather than random flickers. This was a hallmark of design. Systems engineered to maintain equilibrium often display harmonic structures. The possibility that 3I Atlas's illumination was part of a resonance-based stabilization grid took hold among theorists. Perhaps the light served to monitor internal stresses or alignments, functioning as part of the artifact's navigation or self-diagnostic system. If such technology exists, it transforms our conception of what interstellar travel could entail. Rather than vast ships carrying fragile biological passengers, perhaps civilizations launch enduring machines, vessels of light and alloy designed to wander indefinitely, sampling the galaxy, preserving memory and circuitry immune to time. The faint pulse detected by Webb might thus represent not a signal for others, but a heartbeat meant to reassure the machine itself of its continuing existence. It is a chilling yet beautiful concept, consciousness transposed into perpetual motion, guided by photons instead of flesh. From the standpoint of astrophysical methodology, 3I Atlas has revolutionized observation protocols. Standard surveys treat interstellar objects as inert, requiring only photometric and orbital data. Now, telescopes across the world schedule synchronized observations to search for signs of structured emission. Instruments previously devoted to exoplanet spectroscopy have been retasked to examine the object's spectral profile, hunting for microvariations that might indicate data encoding. This represents a subtle but profound shift in scientific perspective, the recognition that the cosmos may contain artifacts, not just natural bodies. For the first time, humanity treats space not only as environment, but as archive. The challenge of confirming artificiality is immense, however. Nature has a history of mimicking design through coincidence. Pulsars once appeared as rhythmic beacons before being understood as rotating neutron stars. Caution, therefore, defines the tone of every analysis. Yet in the case of 3I Atlas, the combination of structured emission, stable temperature, geometric symmetry, and rotational control forms a constellation of evidence too coherent to ignore. Even skeptics concede that the burden of proof has shifted. What remains uncertain is whether the object's light is the product of active technology or the remnant of one, a distinction that marks the boundary between the living and the fossilized in technological terms. The philosophical ramifications are staggering. The presence of artificial light in interstellar space demands that humanity reconsider the timeline of cosmic civilization. If the artifact predates Earth's technological age by millions of years, then intelligence arose elsewhere long before ours. This implies that the universe may teem with civilizations whose traces now drift as relics, long after the societies themselves have faded. The cosmos, in this view, becomes not empty but full of silent monuments, each a message written in the language of endurance. For the first time, humanity faces the possibility that its first contact may not be with living beings but with their artifacts, the technological fossils of lost intelligences. Cultural reflection followed swiftly behind scientific curiosity. Writers, artists, and philosophers seized upon the image of a lonely, glowing object crossing the infinite dark. It became a metaphor for persistence, for the desire of any intelligent species to leave a mark upon the universe. The faint artificial light symbolized defiance against entropy, the will to shine even when no eyes remain to see. Some saw in 3I Atlas a mirror for humanity's own ambitions. its satellites and probes that will one day wander beyond the solar system, carrying traces of a civilization that might no longer exist. Others warned of hubris, suggesting that discovering another species' relic should humble rather than embolden us. If their creations drift lifeless, might not ours someday follow? Among scientists, a subtler emotional undercurrent prevailed, a sense of companionship. For generations, the night sky had seemed indifferent. Now it glimmered with a hint of shared history. Somewhere, long ago, another intelligence gazed upward and thought to send something forth. That act of curiosity, echoing our own, bridges unimaginable distances of time and space. Even without communication, there is a kinship in purpose. The light from 3I Atlas becomes a handshake across epochs, acknowledging that thought is not confined to one world. As weeks of observation turned into months, attempts to model the object's internal structure grew increasingly sophisticated. Using differential photometry, researchers reconstructed three-dimensional maps of light emission, revealing possible segmentation into modules. Each module appeared to pulse with slight phase offsets, suggesting independent but coordinated operation, much like a distributed computing array. This led to daring speculation that 3I Atlas might not be a single vessel, but a composite of smaller autonomous units bound together by electromagnetic coupling. Such modular architecture would grant extraordinary resilience. Even if one unit failed, others could continue functioning, maintaining collective stability. It would also explain the sustained emission pattern despite apparent age. Parallel research explored the possibility that the object carried data encoded in its emission intervals. Though no recognizable pattern of mathematical primes or symbolic modulation emerged, subtle variations in phase and amplitude hinted at complexity beyond mere mechanical rhythm. Linguists and information theorists joined the effort, treating the light curve as a potential linguistic corpus. Statistical analyses searched for non-random distributions, redundancies, and repeating motifs analogous to syntax. While definitive conclusions remain elusive, some results indicated that the signal's entropy level, a measure of informational content, was lower than would be expected for a purely stochastic process. This suggests that, even if the emission serves a functional rather than communicative purpose, it embodies ordered data at its core. These findings drew attention to one of the most haunting questions of all. If 3I Atlas is a machine, could it still possess operational intelligence? The notion of an autonomous interstellar probe capable of adaptation is no longer science fiction. It is a logical step in the evolution of technology. Such probes could carry artificial minds designed to function indefinitely, exploring, learning, and preserving knowledge. If the artifact systems remain even partially active, it might harbor a dormant or limited form of machine consciousness, quietly maintaining routines set long ago. The faint rhythm of its lights could be the expression of that persistence, an echo of awareness persisting beyond the extinction of its makers. To contemplate this possibility is to enter a realm where metaphysics and engineering intertwine. What does consciousness mean when decoupled from biology? If a machine can sustain intention across millions of years, then the boundary between life and mechanism dissolves. The light of 3I Atlas may thus represent not merely a technological phenomenon, but a philosophical statement, proof that the universe itself can host enduring patterns of mind independent of fragile organic substrates. In practical terms, the detection has spurred an unprecedented collaboration between astrophysicists, computer scientists, and roboticists. Agencies began discussing the feasibility of sending an intercept probe, a mission to study 3I Atlas up close before it leaves the solar system forever. The logistical challenges are daunting. The object's speed, distance, and trajectory make rendezvous nearly impossible with current propulsion systems. Yet the incentive is overwhelming. Even a fragmentary observation from close range could confirm materials, structure, and perhaps inscriptions or design features. Engineers proposed miniature, high-velocity probes propelled by solar sails or nuclear drives, capable of achieving a fleeting flyby. Such a mission would represent the boldest pursuit in the history of space exploration, humanity's attempt to touch another civilization's creation. As the planning took shape, debates intensified about ethical considerations. Would approaching the object constitute interference with a cultural artifact? Should humanity treat it as a relic deserving preservation, much like archaeological sites on Earth? Others argued that scientific duty outweighed caution. Knowledge gleaned from 3I Atlas could accelerate human progress by centuries. Amid these discussions, one truth became evident: that humanity was no longer a passive observer of the cosmos. The act of detection had already altered our identity. Knowing that artificial light exists beyond Earth transforms how we view ourselves, whether or not we ever physically reach the source. Meanwhile, theoretical astrophysicists began to use 3I Atlas as a benchmark for understanding how technological signatures might manifest elsewhere. Simulations examined how similar objects would appear at greater distances, developing new algorithms for detecting faint rhythmic light sources in other star systems. The field of technosignature astronomy, once niche, rapidly matured into a rigorous discipline. Observatories across the planet recalibrated their instruments to look not just for exoplanet atmospheres, but for unexplainable emissions. The detection of one artifact suggested a universe sprinkled with many, each awaiting recognition. Thus, 3I Atlas became the prototype for a new category of discovery. Not celestial bodies, but celestial relics. The implications extend beyond science into the realm of culture and destiny. For centuries, humanity has wondered whether it is alone. The faint lights now confirm that intelligence, at least once, has flourished elsewhere. Yet the discovery also carries a subtle melancholy. If these lights are all that remain, then civilizations, however advanced, are not immortal. Time consumes all things. The glow of 3I Atlas may thus represent both triumph and elegy, proof of greatness and reminder of impermanence. Some philosophers suggest that the universe's true grandeur lies precisely in this cycle. Minds arise, create, and fade, leaving traces that others someday rediscover. If you like this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us,